All right, today we are on the B part of the previous lesson, graphs of other trig functions. So remember the A lesson, the beginning part of this was tan and cotan. So now we're going to add in secant and cosecant. Now this is where if you've been really working hard on sine and cosine, this is going to pay off for you because I can, with one little extra step really, convert your sine and cosine graphs into secant and cosecant. So hopefully this won't be too stressful. Now a little warm-up problem, let's just review. Let's take a look at our trig function, cotangent. So remember our period for this is a single pi over b, and b is always the coefficient on x, so pi over 1. Let's just list it as pi. And then I'm going to do my vertical asymptotes underneath here. We're going to take our expression with x, which has that minus pi over 2. And we're going to set that equal. Now for cotan, we have to keep it straight, cotan versus tan. So for cotan, so think about your graphs. They have vertical asymptotes because they're really fractions, rational functions. Cotan is cosine over sine. So we're thinking about when sine is 0. So sine, of course, is 0 on the left point and the right point. Now, I just remember left and right for cosine, top and bottom for tan. So I'm going to set this equal to 0 and equal. So we're going to have to add. And we're going to do a little math. 0 plus pi over 2, I can do that in my head, that's easy. And then 1 pi plus pi over 2, 1 plus a half, 1 and a half, 3 pi over 2. Yes, it has a phase shift, it's moving the graph to the right, but we calculated out our asymptote, that's going to adjust it for us, we don't have to do anything else. All right, let's start by plotting our asymptotes. The first one's at pi over 2, and then 3 pi over 2. I'm going to draw my dashed vertical lines. I'm going to draw close, we won't cross or touch. All right, we need the point, of course, in the middle. So you could either average pi over 2 and 3 pi over 2, add and divide by 2, or mental math, directly in between 1/2 and 1 1/2, 1. Now, cotan, negative lead coefficient, so it's kind of the opposite or reverse of how sine, how positive negative slope works on a graph. So negative is going to rise to the right, all to the left. Okay, we need a second full period. I'm going to add mine on to the right-hand side here. I want to label that. Our last vertical asymptote was at 3 pi over 2, and I'm adding a full period. Our period was pi. So 1 1/2 plus 1 would be 2 1/2. I'm just going to write that as an improper fraction, just so it fits a little nicer. Same thing, we need to figure out what's directly in between 3 pi over 2 and 5 pi over 2, or in between 1 1/2 and 2 1/2. And I'm going to repeat that same blue curve. Okay. So just a review of cotan, and remember we did tan in the previous lesson before we get into our secant and cosecant. So everything you know about sine and cosine is also going to be true here for cosecant and secant. So think back to sine and cosine. The period for those are 2 pi over b. The amplitude is still the absolute value of a, and to do your increments, it's still the period over 4. So all of that works the same. Now, different of course, these have vertical asymptotes. Why? Cosecant is really a rational function. It's equivalent to 1 over sine. So our vertical asymptotes are going to occur when sine is 0. So where is sine 0? So really, back to this warm-up problem, I'm going to go back one more slide. I'm going to think about the same graph. When is sine 0? Well, sine is 0, it's 0 in pi. So I'm going to use that same, that's why I did that warm-up problem. I'm going to do the same process. I'm going to take whatever's with x, set it to 0, and pi. All right, so again, let's get into the drawing of these. Very similar, of course, to sine and cosine. So I'm going to list everything the same as I would. Think about this if it helps you. Think if that was just sine of x. We would have the amplitude, absolute value of a is 1. The period, 2 pi over b. B, of course, is your coefficient on x, which is also 1. Our increments, the period divided by 4. I'm going to reduce that down. Remember, that's how you scale your x-axis. No phase shift on this. no center line shift, no vertical shift up and down, but I am going to add on, we do have vertical asymptotes. We're going to take whatever's with x, in this case we just have 1x, and we set that equal to 0 in pi. Okay, I'm ready to draw. So I'm going to draw it just like kind of you would mark it out if it set a sine curve. So amplitude of 1, I scale my x-axis by half pi. So half plus a half, 1. 1 plus a half, 1 and a half. 1 and a half plus a half, 2. So that's going to be 1 full period. Now you could keep going to the right. I'm going to go to the left this time. I just think I have enough room to space it out that way. So I'm going to subtract a half a pi. Subtract a half, subtract another half, subtract one more half. Got it. Okay, so I'm going to start, I kind of draw what I like to call a template. I'm going to start by just drawing plain old boring sine. So remember, sine starts at the center line. Our lead coefficient's positive 1 on our function. A is 1, so we're going to go up to 1, back down to the center line. So I'm going to dash it in. So I've got my hill and my valley. I'm going to do the same thing. I'm going to continue on the other side. So down to 1, center line, up 1, center line. So I have my hill and then the valley. Now that would be if the graph was sine. We are going to convert this into cosecant. So now, I'll be honest, you don't even always have to necessarily list the vertical asymptotes. I see there is 0 in pi to start with. There's going to be more. So I just kind of remember, this is my cheat way, quote unquote cheat way to remember it, is anytime you hit your center line, so we also hit here at 2 pi, negative pi, 2 pi, anytime you hit the center line, we're going to have a vertical asymptote. So I'm going to start by drawing a vertical asymptote through 0, then through pi, then through 2 pi. I'll do the left period in a minute. Now, you can see here we have this green dashed hill, shall we say, between 0 and pi. Kind of looks like a little baby parabola. It's really not a baby parabola, but it looks like a baby parabola to me. So to convert it into cosecant, I'm just going to take that point at the top. It's opening, a baby parabola opens down, so we convert it to one that opens up. Now I'm going to move to the right. We have a little baby parabola that opens up, so I'm going to convert it to a little baby parabola that opens down. And what I'm actually drawing in blue is the cosecant curve. Okay, I'm going to continue on. I'm going to draw another vertical asymptote over here where it hits at negative pi, and then also at negative 2 pi. And then I just flip these quote-unquote baby parabolas. So I'm at the far left here. This guy, of course, little baby parabola opens down, convert it to one that opens up. Here, our little baby parabola opens up, convert it to a down. So these 4 blue curves I have drawn are the actual cosecant graph. So I really just draw the template for sine, or eventually I will do a cosine, and then I kind of flip it into these little baby, quote-unquote baby parabolas. I flip them. So here we go. So for this one, amplitude, let's start with that. Think about if that said sine, of course. Amplitude half, so it's going to be shorter. Period. 2 pi over b. b in this case is 2. So let's simplify that. And then, of course, let's do our increments, the period divided by 4. We could list the vertical asymptotes, do the work. I'm not going to list them this time. I'm just going to show you how to mark them out on the graph. Try to make it easy for you, if we can. All right, so technically, of course, you know this should be shorter than the last one. I know it's hard to draw it when we're freehanding. I'm going to try to make it shorter, no promises. And we're scaling by quarter pi, our increment's quarter pi, so it should be a horizontal shrink. But again, sometimes it gets a little messy to try to really cram them in here, so I'm going to do the best I can. Quarter plus a quarter, a half. Half plus a quarter, 3/4. 3/4 plus a quarter. So that would give me 1 full period. You could keep going and add 4 more to the right if it's easier to just keep adding. I'm going to go to the left this time. So I'm going to subtract a quarter. Subtract another quarter, subtract another quarter, and subtract 1 more quarter. Got it. Now I'm thinking about, I'm going to first draw my curve, my template, what I like to call it, for sine. Sine, of course, starts at the center line, and we're going to have the hill up to a half. Here's my hill, and then the valley. Now some kids can see it right from that. They don't necessarily draw this full dashed line in. which is totally fine. I'm going to draw the dashed line in just for the sake of trying to make it easy on you. Okay, I'm going to continue on over on this side. So I have my hill, and then I have, of course, my valley. Now, to convert into cosecant, I'm going to start on the left and just work my way across. Any point we hit our center line, or it kind of splits those baby parabolas apart, we draw our vertical asymptotes. So baby parabola opens down, I flip it to an up. Same thing, I hit the center line right there. You can see it splits that little baby parabola that opens up. I flip it to a down. Moving to the right again, hit the center line right here at pi over 2. Splits your little baby parabola. It's one that opens down, so I'm going to flip it to an up. Hit the center line right there at pi. My little baby parabola opens up. I'm going to flip it to a down. So technically those 4 blue curves are the cosecant curve. Okay, let's do one more cosecant curve, and then of course we will do sine. This one has a phase shift, so we can practice doing that. So again, think of that if it just said sine. Think of everything we have to write out for sine, or know for sine. Amplitude, absolute value of A, absolute value -1, 1. Period, 2 pi over B, B is 2. Increments, period divided by 4. And this one we do have the phase shift. It's going to move left and right. So I'm going to abbreviate here, phase shift. Don't forget to calculate that. Think of it as you solve for x basically. If I want to get x alone here, I'm going to add pi, and then I have to divide off the 2. So it's going to move to the right, pi over 2. It's going to be shoved down to the right, so to speak. So just mark it out as if it was your sine curve. Okay, so amplitude 1. Now, phase shift. First thing we have to label on here, our new starting point, pi over 2. So think of that as 0, 0. I need 4 increments past it to make 1 full period. So from my phase shift, from my starting point, I'm going to do the math over here. From my starting point, we're going to add our increment. So a half plus a quarter, 3/4. Here's my next mark. Now I'm going to add another quarter to that. And you can get to a point where you're doing this in your head, of course. 3/4 plus a quarter, 1. I'm going to add in my head. 1 plus a quarter, 1 1/4. I just wrote it in proper. 1 1/4 plus a quarter, 1 1/2. Now it's your choice if you want to continue on to the right or of course go to the left. I'm kind of in the zone of adding them, so I'm going to keep going to the right. So I'm going to add 4 more. 2, 3, 4. So 1 1/2 plus a quarter, 1 3/4. I really didn't write that messy. Come on, smartboard. 1 3/4. I'm going to put it as 7 pi over 4. 1 3/4 plus a quarter, 2. 2 plus a quarter, 2 1/4. 2 1/4 plus a quarter, 2 1/2. So again, just like the last one, I'm going to start with pi over 2, my starting point because we have the phase shift. Think of it as a sine curve, but catch you have a negative for your lead coefficient, aka a reflection. So I need a valley, so I'm going to go down 1, back up, and then a hill. Because we have the reflection. I'm going to dash it on. Again, some kids can just plot the points and see it. So there's one complete period. Valley and a hill, continue on, valley, hill. Got it. Okay, that is sine. Now we convert it into cosecant. So any place you would be touching the center line, I'm going to work left to right. You're touching the center line. We're going to draw our vertical asymptotes through those points, because that's where it breaks apart our little baby parabolas. This guy opens up, so I'm going to flip it to a down. Same thing, we hit the center line right here, so I'm going to draw another vertical asymptote. Opens down, make it open up. Center line again we hit. Little baby parabola opens up, so I'm going to flip it to a down. Hit the center line again. Open down, open up. So if you were good at drawing sine and cosine, secant and cosecant are going to be very, very simple. And notice, I did not list the vertical asymptotes on this. I just drew it, and you can too. All right, so secant, of course, think about everything you know for cosine, because they are related. Period, of course, 2 pi over b. Amplitude, absolute value of A. Increments, of course, are your period over 4. Now, I do like to talk about why there are vertical asymptotes, because clearly there will be on this one. There are vertical asymptotes because secant is really 1 over cosine. Whenever you have a fraction, you can't divide by 0. 0 under the line is undefined, so that's where our vertical asymptotes occur. So again, I'm thinking about those quadrant angles, the 4 points. Cosine equals 0 on the top and bottom, because remember cosine are your x coordinates there. So we are at 90 degrees, or in radians pi over 2, and then make it easy, I would just call this one negative 90, negative pi over 2. So you'll take whatever's with x, set it equal, plus or minus pi over 2. Now again, I'll be honest, I don't get crazy and memorize all of this for the vertical asymptotes. We can just draw it on the graph, and I will show you that. So let's just do our parent function, of course, secant. Think of it if it said cosine. All the things we need to know for cosine. We need our amplitude, absolute value A, period, 2 pi over B. B, of course, is 1, so over 1 we got it. We need our increments, period, divided by 4. There's no phase shift. Now I'm going to list it just so we have them, but again, I'll show you how you can do it just on the graph. So, of course, our vertical asymptotes. We have it because it's really a fraction. Secant's really 1 over cosine. It's going to have it on cosine 0, which, of course, is at 90 degrees and negative 90. I just have them, of course, listed in radians. All right, so we are going to start, same thing. I'm going to kind of start with a cosine template, so to speak. All right, amplitude of 1. I'm going to scale my x-axis, of course, by pi over 2, half plus a half, 1 plus a half, 1 and a half, 1 and a half plus a half. Clearly, I'm out of room kind of if I continue to the right, so I'm going to go to the left now. So I'm going to subtract a half, subtract a half, subtract, and negative 2 pi. Got it. Okay, so cosine, remember, starts at the A, the amplitude. So I'm going to do my template for cosine. I'm going to start up here, back to the center line, down, center line, up. So remember, I'm going to dash it on cosine 1 big valley. Got it. I'm going to continue on the other side. I should have 1 big valley. So I'm at my max height of 1, center line, lowest point, center line, highest point. So I'm going to dash it on my 1 big valley. Now, you can see we have the asymptotes written on here at plus or minus pi over 2 to start us off with, which it's the same deal as it was for cosecant. Any point you hit your center line, which I see there's 4 of them, we're going to draw our vertical asymptotes through. So now I'm going to convert this into secant. So same thing as what I was doing for cosecant. Here we have this up parabola, I'm going to make it a down. Here we have a down parabola, I flip it to an up. Up parabola, down. Now we got to be careful on this because it's the ends that sometimes get us. On the far left end, we have the right side of a down parabola, so I have to flip it to the up side of a right parabola. Same thing, on this far right end, we have the left side down parabola, so we need a left side up. So on the ends, sometimes you do get stuck with only part of the parabola. Don't miss them, you need to flip them. Okay. Oh, that rhymes, who knew I was a rapper? Okay, so secant, think of it in terms of cosine. That said the same thing, but with a cosine there. And write down everything we need. We need our amplitude, absolute value A, period, B, B of course the coefficient on x, still 2, increment, period over 4. Now this time I'm not going to get crazy and write down the vertical asymptotes. We're just going to do it straight off the graph. Now technically it should be shorter, a half or a height, but you know my drawing skills, no promises. No promises. A little shorter than the last one, how's that? And this time we're scaling by quarter pi. So it should be a horizontal shrink, but it gets a little messy if I try to make them too tight. Quarter plus a quarter, a half, half plus a quarter, 3/4 plus a quarter. So there's 1 full period. I'm going to do my other period to the left, so now I'm just going to subtract. So there's the negatives of the same we got, the same values we have. Okay, so cosine, remember, starts at the A, but be careful, we have technically a reflection here. Our A value is -1/2, so we're going to start down here at -1/2, up to the center line, up to 1/2, center line. So we have, this time, one big hill. Since we have the reflection, I should have a big hill on the other side. I'm going to continue on. I'm at my lowest point, so I'm back to the center line, 1/2, center line, down the 1/2. Same thing, I'm going to dash mine on. One big hill. Now I'm going to convert it into secant. I'm going to work left to right. So first I'm going to start right here where we touch our vertical asymptote, center line, center line. So many dashed lines, I tell you. Center line. Okay, I'm going to work left to right again. So I see on the left here we have an up right parabola. So I'm going to make a down right parabola. Little baby parabola opens down, we're going to flip it to up. Little baby parabola opens up, make it down. Down parabola, up. Here we have the 1/2 again, only part of it. We have the left up, so I need a left down. So like I said, you just have to be careful. A lot of times on the ends, you only have 1/2 of it. All right, one last one to graph, my friends. Let's do one with a vertical shift. You see you have that +2 on there, so that's going to move it up to just a good review of how to change your center line. So think of this, I'm going to rewrite it. Instead of secant, I'm thinking about it saying cosine, if I had to graph that. So of course my amplitude, absolute value of A, period, 2 pi over B, B of course 4. I'm going to reduce this down. Increments. We're going to have our period divided by 4. So we're going to have to do a little work here, a little fraction work. You really think about doing a 1/2 divided by 4. When you divide a fraction, you multiply by the reciprocal. So it's really a 1/2 times a 1/4, which is an 1/8. Ooh. Very tight. It's going to be hard for me to draw that accurate, okay, just for the record on that. Now this one, I'm going to list it also because we have this vertical up 2. So it is going to change my center line to y equals 2. But again, I'm going to draw this or mark it out just as though it said cosine, and then all we have to do is convert it. Now because you have a center line change, 2, I'm going to start with that. I'm going to draw that on, so here's my new center line. From the center line, I'm going to count the amplitude. So we're going to go up 2 to 4, and then down 2 to 0. Just going to put a point there, so I know my graph's going to be up there between 0 and 4. Now, scaling the x-axis by 1/8 pi. Clearly not drawn to scale. That should probably be a little smaller. So an 1/8 plus an 1/8, 2/8. Let me reduce. 2/8 plus an 8, 3/8. 3/8 plus an 8, 4/8, which I'm reducing. I'm going to go ahead and subtract and do the ones on the left. Obviously, it's just going to be the negatives of these. Subtract an 8, subtract another 8. Got it. Now, same thing. I'm going to start by marking it out as if it was cosine, and then I shall convert it into secant. Now remember, we have the vertical shift up 2, so these are going to be drawn between 0 and 4. So my highest point, of course, on this is up here at 4. And cosine, of course, starts at the A. +2, 2 up, +2, so I'm starting up there. Center line. Down 2 more. Center line. Up 2. So there's my traditional cosine curve, my one big valley. And clearly I'm going to draw that on the other side. I'm at my max height of 4, so center line, down 2 more, center line, up 2 more. So here's going to be my one big valley. Got it. Okay, I'm converting it now into secant. Remember our center line's up here at 2, so anytime we hit our center line, these red dots, our center line of 2, we're going to draw our vertical asymptote. Trying to hit that point. Okay, and now I'm just going to convert that blue cosine curve into secant. I'm going to go left to right. So here I have the right of a down baby parabola, so right up. up parabola, down. Down parabola, flip it to an up. Up parabola, convert to a down. And then here we have the bottom left. So I need an up left. Should wear taller shoes to hit that top point. So if you were good at sine and cosine, use that as a template, convert it into secant and cosecant. Okay, have a great day, happy graphing. Make sure you label everything.